world leading expert for graphene, Dr. Zina, who is, for example, working as the Director General for AMPT and also who is the founder of this organization as well. So for this organization now, actually this is in charge of designing and promotion of the application of advanced materials in the world to address the daunting challenges of mankind. So Dr. Zina has a very specialty in graphene and new materials. So how does that relate to 5G and the industrial internet? Well, let's welcome Dr. Zina to share with us some insights. So the speech is going to be conducted through the video format.
Imagine a world of ultimate connectivity. A world where everything around you is sentient. A world where we do not simply interact with the objects around us, but that the objects around us become an extension of our body and our mind. This is an intriguing picture and window into a very near future. But the question is, how do we get there? Hi, my name is Dr. Zina Jarrahi Cinker, and I am the Director General of AMPT Advanced and Frontier Material Future Preparedness Task Force, a unique and groundbreaking alliance of over 1,000 visionaries, thought leaders, scientists, and researchers in frontier materials that have come together to paint the next chapter for humanity using technology. Being a condensed matter physicist by training and a graphene expert in the past decade, when I was first asked to speak on this prestigious stage, my first inclination was to tell you about graphene. The one atomic layer of carbon, the thinnest and strongest material we've ever known. A material that can be an excellent conductor of heat and electricity, and at the same time, it is transparent and flexible. And the graphene was only the first of its kind that we discovered. Since then, we have discovered a whole family of what we call two-dimensional materials, hundreds of them, at the atomic limit of thinness, with extraordinary properties that we've never seen before. They're a class of what we call frontier materials, the building blocks of the future, the Lego pieces of the future. Materials that are going to be enabling technologies like transparent, invisible biosensor tattoos, sprayable antennas, foundries in a box, the fingertip of every one of us to make the devices that we want. Make wearable kidneys, brain interfaces, flexible and transparent brain interfaces. But then I thought, this is 2021. All of you have probably already heard about graphene. Many of you, the companies in the audience, are already using graphene. Huawei, Samsung, Nokia, you guys are pushing the boundaries of what is possible with these materials. So instead, I decided that I wanted to do something different. I decided that I want to tell you a story. That I want to tell you a story of matter. Look around you. We are physical material beings surrounded and living in a world of materials. Everything around us, everything you touch and you feel is made of materials. The science and art of understanding, decoding, manipulating, and engineering new constructs with materials, making more advanced and more innovating versions of what we had and making new ones that we did not have, is at the core of human civilization. So much so that the human history is marked by ages and eras of mastery of materials for humanity. The Bronze Age, the Iron Age, the Age of Steel that has enabled this modern city and modern construction that we live in. The Age of Aluminum that has enabled modern commercial air travel. The Age of Plastics, only over about 100 years, which has enabled, as is the foundation of modern consumerism and the mass manufacturing. And then the Age of Silicon, the material that has enabled our modern digital era. So what is the next chapter? And that is why I'm standing here today talking to you about frontier materials, the materials of 21st century. The most intriguing thing is that our ability to dream and innovate with technologies is closely bound to our mastery of matter and materials. Even though as we're mastering these materials, as we're studying them, as we're experimenting with them, we have no idea the true extent of the change that they're going to be bringing us. Think of this, 6 or 7 decades ago, on that fateful day in Bell Labs, when the first silicon transistor was introduced, did we ever think that it would be giving birth to all of this? That this little construct of materials, that this little marvel of engineering of matter would be allowing me to be talking to you thousands of miles away, virtually, standing on a stage that does not even exist. With the same token, we are only scratching the surface with frontier materials. We do not know and we cannot predict where they're going to go and what shape of the future they're creating. But you know what? That does not stop us from imagining. So let's give it a shot. Let's imagine. Close your eyes. What is the pinnacle of connectivity? It is man becoming one with the universe. It is man becoming one with his surrounding. To become one with our surrounding, we need to create a seamless bridge between us and the world around us. We need to create a seamless direct bridge between our brain, which is already connected to our body, but we need to create a seamless bridge between our brain and the world outside, the objects outside. We need to create a seamless bridge between our physical movements and the constructs, the objects, the machines that we are surrounded by. The essence of this bridge and connectivity is in a physical phenomena called conductivity. Conductivity is what allows a transfer between two states, the transfer between two beings, the transfer of electrons, information, energy, sensing, acting, reacting. And that is why the next generation of sensorial, interfacial, conductive materials are going to be enabling us to have the next leap in ultimate connectivity. What if we could turn every surface and every object around us conductive, sensing, acting, and reacting? What if we could turn every glass, every bottle, every window in every building in the world conductive using 2D materials, where they do not only become displays, harvesting and storing their own information and energy, but that they could become a sensing and communicating component in our life? What if we could turn our drinking glass into an object that could tell us the composition of the drink that we're having? What if we could make and turn our hair conductive? An extension, a sensory extension of our body, transmitting and storing information. What if we could create the seamless interface between our brain, our neural network, and the objects that we have made sentient? A connective bridge between us and not only just cars and devices and phones, but between us and the clothes that we wear, the walls that we live in, and the grass that we walk on, and the bricks in the buildings that we live in. What if the buildings of the future, made of frontier materials, could not only tell us about every component, every crack, every strain, every problem, but they could sense us, that they could move and they could shift physically and architecturally based on what we thought? What if the walls around us could not only display what we're thinking, and our clothes not only sense our state of mind, our physical symptoms, and releasing medication for us because we're not feeling well, but what if the bristles in our rug, in our bedroom in the morning turn soft? Because our rug already knows that we're not feeling well and we're in need of a little bit of TLC. What if we could create a bridge between us and the trees? that we could sense what the trees are sensing, and that the trees could talk to us and communicate with us and tell us what they need and give us what we need? What if we could connect with everything around us? And to do that, we need to create a bridge between us and these worlds. And to make that a reality, we need to transform the way that we think and we do materials innovation. Not in the isolation of research labs, not bound by geography and disciplines and industries, not the way that we are doing it now. We need a different kind of ecosystem, a superior, connected, evolved, and hybrid ecosystem. And that is why we founded AMPT, to create a new model, and a global infrastructure for frontier materials innovation, crossing boundaries and borders, crossing geographies and disciplines, devising a worldwide strategy and aligning international activities to fast-track the materials of the future, making an impact on our world today. But to do that, we need you. For frontier materials to seep into every field, every industry, we need to partner and we need to develop the next chapter of technology together. So let's imagine together. Let's imagine a world where everything around us is sentient. A world where we become one with our surrounding. A world of ultimate connectivity. How do we get there? We just might know how. Will you join us?
Well, thank you very much. Zina has done a wonderful sharing about the frontier materials, new materials, and also the connectivity enabled by that. And also you open our eyes to, so for the future, how can we have a better merging between us and nature, between us and the earth? Well, this is a refreshing idea. I believe that in the era of 5G, in the future, 5G is going to become a very important, fundamental, basic scientific discipline. This is an area where we are going to engage the help of a lot of leading technicians and researchers in the industries as well. So thank you very much, Dr. Zina, for your excellent sharing. Okay, without further ado, we are going to have with us a very, for example, special presenter representing a very special wearable company innovator. So Mr. Enreal, so Xu is represent Enreal, who is a specialist doing research about the human wearable devices. This is a high-tech startup company. For Enreal's product in the era of 5G, this is addressing the pain points for us. We're thinking about, say, for the era of 4G or 3G, all the way through 3G, 4G to 5G.